Hello friends, I am Mohammad Waleed and you all are watching Academics with EMW. So in the last video we discussed the conduction heat transfer law, means that was Fourier law of heat of conduction, and we discussed some of its parameters and check out some of the thermal conductivity values as well. Now in this video we are going to discuss what is the convective heat transfer law, which is of course Newton's law of cooling. So without any further delay, let's check out this video and let's get the ball rolling. Newton's law of cooling. So Newton stated that heat transfer rate is directly proportional to the surface area of the body and the difference in temperature between the body and the surrounding. So now let's decode it with the help of expressions here. Q is directly proportional to Ts minus T infinity, where Q is your heat transfer rate, which is not simply the heat transfer, as we are talking about here heat transfer rate. So in heat transfer rate we have joules per second, and that is also equivalent to watt. Ts is your surface temperature and T infinity is your fluid temperature. Now as the temperature difference would be high in between your surface and the fluid, more heat transfer rate would be happened. And Q is directly proportional to AS, where AS is your surface area of the body. We all know that as we extend or expand our area of the body, there would be more chance of fluid interaction with that body. So as much as there would be surface area, more will be heat transfer rate. Now let's remove out the signs of proportionality and brings the signs of equality, which brings us the Newton law of cooling equation, that is Q is equal to H multiplied by surface area multiplied by temperature difference. Now here H is convective heat transfer coefficient, having a unit of watt per meter square Kelvin. Now its unit we can all find out by manipulating the H and take it out all the terms on the other side, and taking H on the one side we can find out its unit. It is watt per meter square Kelvin. Now let's understand Newton's law of cooling with the help of example. We have a body having surface area AS and your temperature of the surface is Ts. Now let's say our fluid is moving over it like that, and let's say this fluid is your air only and having a temperature T infinity, so it is moving over your plate. Now if let's say your plate is at the higher elevated temperature, then heat is going to be transferred from your plate or the body to your fluid, and vice versa in the other case. Now this was all about the Newton's law, but it also the convective heat transfer also depends upon some factors. What are they? Fluid velocity. As much your fluid is traveling fast, more chances of heat transfer would be there. It depends upon fluid properties like density, viscosity and thermal conductivity, etc. Also it depends upon the shape object. Is it square, it is round, flat, rough, smooth, and at the last it depends upon orientation of the object as well, whether is it placed at the inclined angle or the 90 angle. So these things matters in the convective heat transfer. So this was all about Newton's law of cooling. Hope you understood that particular concept. So friends, if you gain some of the knowledge from this video, then kindly like this video, share it with your friends. And if you want more of these kind of videos in future, then kindly subscribe it and hit the bell icon. And if you have any query present for this video, then do comment in the comment section below. Now in the next video we are going to discuss what is radiation heat transfer law in a detailed way. So till then, bye bye.